Okay, without further ado, let me introduce our first speaker today, who is Omer Agmon from IBM Trusteer, who is going to talk about Client Maximus raising the bar. Omer.
Thank you very much. So, I'm Omer, works at Trusteer IBM. Start with a little bit about me. I'm a malware researcher. I used to work at software engineering. Last couple of years works at IBM researching malwares, and my specialty are financial malwares. Hobbies include the reversing of electronics, hardware, and stuff like that. So what we're going to do here, basically I want to tell you a story. The story of Client Maximus, latest version. That's why it's last minute. Because it happened last month. And the entire story basically happens in less than 1 second, written by several authors. And I'll try to break it out step by step. There are going to be some very technical slides, a lot of code, different languages. So try to bear with me if you understand everything. So I want to talk to you after the lecture to hear to understand myself. I'm joking, but I'll try to give you some background about the Latin America malware scenery, which is pretty uncommon usually between the malware researchers, and the Client Maximus actual flow. So we're going to talk about some evasive and injection techniques displayed here. Some of them are written in PowerShell, some of them are native. We're going to go over that as well, but basically we're trying to tell the entire story as a whole, and hopefully you can get something out of it, obfuscation techniques, injection techniques, anything. So let's start with Latin America. How many here have experience with Latin America malwares analysis? Great. So as you probably know, usually until recently, written in Delphi or .NET code, VB.NET, C#. They have like afternoon classes where they teach and points to links in GitHub where you can download the actual malicious payloads. And they pretty much looks the same, unsophisticated mostly. Their MO is pretty simple. They just iterate through the different windows looking for the title that seems like a bank title. The encryption is usually XOR-based, and we've seen many samples using the exact same XOR encryption. So it's pretty hard to write a decryptor and then reuse it everywhere else. But Client Maximus pretty much changes that. Recently, in Latin America, banks started to have their own applications installed on Windows machines, where the application itself is the one accessing the bank, not a web browser. Client Maximus knows that and utilizes that. We spotted the first at the 2016 at fall. And the payload itself is written in C, which is pretty uncommon to Latin American malwares, and uses up-to-date stealth techniques, which is also pretty uncommon. And we've seen a very complex infection flow, which we'll go over. Mixes of languages, mixes of techniques. This is the entire flow. As you can see, it starts from the top left corner. And the purplish boxes are the executions, the actual executions, new processes. The light blue are the CNC communication, the downloads. And the yellow are kind of actions that it performs to assist in the process. So we go over this flow. Let's start with the link file because it's pretty interesting. But before that, just a question. Why do that? Why make the whole infection process so cumbersome and convoluted? So the first reason, of course, would be to evade antiviruses, because we want them not to recognize what we're doing, the malicious stuff, make it hard to reverse engineer. But we also see, of course, evidence of copy-pasting code and several programmers. And maybe this might be the evidence why it's so easy to take copy-paste from Stack Overflow, paste it, and then make a lot of money out of it. which is what Client Maximus does. So as I said, the first step is the link file. Usually, the link file executes cmd exe with some parameters that we'll examine thoroughly. Link file is a shortcut file in Windows, and it's interesting that Windows only show you 60 characters, from the entire payload of the link file. But this link file actually has 540 characters, so it's pretty obfuscated by any Windows UI that you right-click on the link file and click on properties. So you have to use some kind of a hex editor or some kind of a parser. I basically tried to write my own parser for that, and after that, when I found out the entire payload, eventually I found 010 plugin for that, so it does it very nicely. And let's look at the payload itself. Okay, so the bottom part is the payload. You can see it has several parts. The first part is the CMD actual execution. So you can see that it executes the CMD with the /c, of course, and then have some kind of weird string marked in red. After that, we have the actual base64 payload, which is the green one, and eventually the last bottom line, we see the -wi1. So let's go over that a little bit, okay? Let's try to figure out what's going on there. So you can see the, if you know VBScript, right, in Windows, so you can, of course, identify the percentage symbol used for variables. But when cmd-exe uses the /v command line parameter, it means that every variable that you defined, it will immediately get its value, and you can use that for execution right after you defined it. Okay, so that's exactly what it does. This is the exclamation mark on the third line. You can see that it basically creates a string PowerShell. So that's the first obfuscation technique that uses in order to bypass anything that looks for the string PowerShell. Next, you can see that it uses the PowerShell.exe -e. The e flag is, of course, the base64 payload itself, and then -wi, which is the window style hidden, which means that the window will be invisible. This is important for the next stage. So when we decode the base64 string, we get this, which is, you can see a little bit obfuscated PowerShell, right? Written like a hacker style capital and lowercase letters. But if we just rearrange that, we get this string, which means clear host, invoke expression. Invoke expression, for anyone who doesn't know, is like eval in JavaScript. It just takes a string and executes the string. And what it executes is another payload it downloads from the internet, from its CNC. So why does it do clear host, right? It's a new window. Okay, so it doesn't have anything to do. Clear host is like a CLS in command line or clear. And this is strange, and this is the first evidence of just copy-pasting some code from the internet, using that, and getting the final result. This method of using PowerShell to execute immediately a code that was downloaded from the internet was spotted by Unit 42. Unit 42 is a part of the Palo Alto group, and they call that IEXDX because of the invoke expression download string initials. And they have many, many others method. I put a link in the description. The presentation will be available for download, so you can do that later. So that's the second part, where it takes this PowerShell script and downloading the string and executing it. Okay, so we're moving up to the PowerShell execution. This is the script that has been downloaded. And you can see that the first thing it does is download another string from this URL. And you can see on the second line, if you know PowerShell, it load means basically load an assembly, a .NET assembly. And on the third line, it executes a method on that assembly called go. And that assembly receives another URL, which is happens to be the same one. And then it sends parameter, and it starts doing a lot of stuff. Basically, all the rest of the code here does two things: create the VBScript file, which will execute which will be executed later. We'll go over that, and create another link file that will execute the VB file. So let's go over that next step of the actual what's going on in the DLL downloaded. Just to remind you, we're talking about downloading a .NET DLL, loading it, and calling the go method on the third line, right? So this is the DLL. So it's not obfuscated. You can check it out in ILSpy or any other reflector. You can see the isVirtual method. IsVirtual is checking for virtual store. Virtual store is a feature since Windows Vista that basically used to take legacy apps from Windows XP, which tries to write, for example, C Windows System 32, and they give them some special virtual folder under local app data. So this malware checks that it's not running there. It also, we also have the algorithm for generating a file name randomly. You can see that it should contain the string install, update, setup, so pretty easy to understand if it's related. Another method might be relevant is create random dir, create dir random. You can see the exact conditions if you want to create a regex or some rule or a signature to try to catch that. Pretty easy, unobfuscated. Same for the random string. Okay, this is another part of the same DLL that was downloaded. And the actual go method, which is this one, is the one who does the actual work. So first it checks if it's in any kind of Brazilian IP. If it doesn't have any Brazilian IP, it won't execute. Then it checks for some software installed. So what are the software installed? As I said before, in Latin America, they moved to software, special software that only with those software you can connect to the bank and do the transfer of money. So they check for that, for security software. And only if all conditions are true, they continue to the next stage of the payload, which is actually taking the files from the server. So we see here a 4-file payload, which we'll examine further on. And you can also see the check for the business of the operating system, which might be important. Because the payload of the Client Maximus is native, it's written in C, it has to be corresponding to the OS of to the business of the OS. So this is the 4 files payload. You can see in the middle the doctor file, and the one below that, the VBScript, are the 2 files that were created in the original PowerShell, if you remember. So the doctor only executes the VBScript file, that's it. And we can also see the wherefore.exe.config, which is a .NET config file. So basically a config file in .NET, you can have some conditions about what to execute when you execute the .NET. But in this config file, all you have is which runtime versions are supported, which are 2 and 4. So assuming that 1.1 has long been gone, this is basically another evidence why download this file if it doesn't do anything except saying the supported runtimes are 2 and 4. It's really has no meaning. So it is another evidence that it just copy-paste of some code or just seeing something on the internet, downloading it and using it as is without any change. And we, of course, have the payload, which is the last line, the one without any extension. And we also have the encoded PowerShell, which is the third PowerShell that we see here, which we'll go over. And then we are currently at the stage of executing, creating the VBScript and link files, which we've seen in the first PowerShell, executing the link file executes the VBScript file. The VBScript file looks like this, okay? Creating an object of type shell, calling the run method, okay? Which is a standard method of doing that. But you might ask yourself, why doing the first parts in PowerShell, this one in VBScript? So this is an evidence that all of the parts was not written by the same people. And the folder names, you can see that it corresponds to the regular expression we examined before, 6 to 16 characters, etc. And all it does, it takes the current folder and put that in the script itself. So we're getting now to the execution of PowerShell exec, which we'll talk about in a second, and decrypting the PowerShell script. Okay, so what is PowerShell exec? PowerShell exec is a legitimate software. What it do, it helps IT administrators execute PowerShell scripts that have some sensitive information like password and stuff like that in an enterprise or organization where they don't want the endpoints to have the password as a clear text. So you can, it's have a UI, a very nice UI. You can just take any PowerShell file, put a password, it scrambles it up, and then it's very hard to reverse engineer the software itself because even if it's written in .NET, it has a very, very good obfuscation, which we'll talk about in 1 second. But that software is being used all over. You can take your own script with the password inside, encrypt it, distribute it, right, propagate it in your endpoints, and then execute this software in order to run the PowerShell itself. So the PowerShell exec itself uses very up-to-date obfuscation techniques. So, for example, code emission in .NET is a real pain in the ass for reversers because it basically takes existing code. It translates the code into a byte array. It translates actually the IL, the intermediate language of the .NET code, to IL, to byte array. Then it stores the byte array somewhere inside the assembly. And then upon execution, it loads it and executes that. So standard reflector won't help you, right? Like ILSpy or red gates or stuff like that. But there's a reflector called DNSpy, which is another open source project based on ILSpy, which basically knows to debug this code up to the point of the code emission loading, and then it translates that immediately to your favorite .NET language. Mine is C#, so it just shows the C# code. So this technique is familiar, right? It does assembly.load. It loads the .NET assembly. Activator create instance is the way that to create the instance. And then using method info.invoke, which is another reflection method in .NET, it just executes the code itself. And it does that with multiple threads, which are being synchronized in order for you to have really hard time when you debug it, right? Because you always jump from point to point and you don't really have anywhere to stop and just go over the flow synchronously. And of course, all the usual obfuscation techniques, which are Unicode characters, Unicode strings, methods, class name, everything is Unicode and nothing is an actual character that you can work with. So my point is it's very hard to, it is feasible, but it's very hard to reverse engineer. Lucky for us, the script was not encrypted with a password. The Client Maximus script was actually only base 64 encoded, so it was very easy to just translate it back to PowerShell. And because it has two methods, right? The PowerShell exec, you can either encrypt it or you can encode it. So they choose not to encrypt it. Cool. So it's faster for us. An interesting fact about PowerShell exec, I said it's a legitimate software. We published our blog at the 12th of September last month. And it had a 0 out of 64 in virus total. And since the publication, you can see the rise on the left column. For the guys in the back, I'll just say that 6 days after that, it got to 2 identifications as a malicious software. And currently, it's 8 identifications as malicious software since the publication. So interesting fact. Before that, it has 0. Okay, so we've gotten to the last part of the payload. What actually happens here is the heart of the process. Basically, when you have a malware, you want it to inject itself into an existing process that is elevated, preferably, or you want to create an elevated process and you want to inject yourself into it. So Client Maximus uses another open source library. This library is called PowerSploitSuite, also available on GitHub, and you'll have the links ready for you in the description below. So this is a very rich PowerShell library that enables many pen testing stuff, like, for example, persistency. You can choose from many different methods of persistency, and you can have different AV signatures checked, right? There's this split class 101 method of AV checks, if anyone is familiar with. If not, you should Google it. It's very nice. They generate many they generate executable. They change it until the antivirus does not detect it as a virus. So it has this capability as well. It can set master boot records, which is a cool feature. And the most important one for related to what Client Maximus does is remote code execution, right? So the way Client Maximus utilizes this library is by using a technique called reflective Pea Injection, right? So usually when we want to inject something into another process, we do a write process memory, and then we do a virtual alloc X if we need, and then we do create a mod thread and stuff like that. So, but we need to do all that in order to take our code and put it in another process, and then our code would probably be some kind of shellcode, which will perform the load library, and then get proc address, and then load the dependencies, and so on and so on. So the reflective Pea injection, what it does, basically, it goes over to the remote process, and it does all this heavy lifting from the remote process, right? So it goes over, let's say I want to inject to cmd.exe. So it goes over to cmd.exe, and then it runs over there in cmd.exe address space. It runs the code that basically do the load library, right? It parses the PE header of the DLL or exit that we want to inject. It goes over the import address table, and then at the remote process, it performs the load library of every dependency, and then the get proc address, and basically it finally takes the execution pointer and puts it in our main, and we have our malicious payload being injected into the remote process, and it does all that remotely and in PowerShell. So if you want to see the source code of that, it's pretty cool stuff. Also available in GitHub, same as before. The link is in the description of this slide. And this is exactly the feature that Client Maximus utilized for that. So we're talking about imitating the Windows loader, as I said before. And the Windows API involved are the same, only they are not being executed on a suspicious process, right? And they're being executed on a legitimate process because it's being done remotely. Okay, so it's another evasive technique. Again, cool feature of this PowerSploit suite. Here you can see an example of the obfuscated PowerShell script. This is the after obfuscation, of course, but you can see that the executable is in clear text after decoding it. And that's it. At this point, we have a cmd.exe. By the way, we've also seen wordpad.exe and svchode.exe, which is infected with the malicious payload, which is a native DLL. Also, it points to the main of the DLL, but if it has some TLS functions or stuff like that, it will also execute those. And basically, that's it. Another thing I wanted to mention about Client Maximus, if we have a chance to talk about it, is its Usc Bypass Method. Basically, what it does, it rides on an auto-elevated feature of Windows that was disabled in Windows 10 Creators Update. So up to Windows 10 Creators Update, it is widely available. What it basically relies on is that you have the event mgr.exe. Event mgr.exe is the event viewer itself. It doesn't have any UI. So it's, the exe relies on mmc.exe, which is the Microsoft Management Console, to be its UI, right? So Windows allows you to write a registry key and replace the executable for the MMC or put another path for it. So the thing special about the event mgr.exe is that in its manifest, right, Windows distributes it with a manifest that has highest available privileges. So every time you want to open that, MMC is being opened with the highest available privileges. So if you just change that registry location you don't change it because by default it's empty, right? And Windows looks up in Windows System 32 for mmc.exe. But if you put your own value in the default value in the registry, in this path, you can put any exe of yours, and if you click on event mgr, Windows will look for the mmc, which will be your file, which will be executed elevated, right? So this is the technique that Client Maximus uses for Usc Bypass. By the way, Windows 10 have a different exe with auto elevation, which is the sdclt.exe. It's some kind of a backup thing, exists since Vista. So you can see in the code, it has a differentiation between, he does RTL get version in order to understand which Windows version it runs on. And then according to the version, it decides which executable to use as an auto elevation. And you can see the subkey on top, and then the decision of which version, and finally the rest of the code will be executing the process according to the version. And that's it. I hope that wrapping up this, I mean, you can go over later on the presentation and the videos. It's a lot of technical stuff, but I hope that you might got anything that will help you using the multiple different techniques of Client Maximus infection process. And now, if you have any questions, I'll be happy.